So here we have electric field. So before that, we have discussion about Coulomb's law. What is the Coulomb's law? So that we have seen the force, electric force, that is 1 by 4 pi epsilon naught into Q1, Q2 by R square in case of 2-point charge. So here we have not considered the vector quantity, okay? So in case of vector quantity, that position vector we have to add here, okay? And later we have electric field intensity. So what is the expression of the electric field intensity? That force experienced by per unit charge. So that expression you have there 1 by 4 pi epsilon naught. Okay, and if one charge is Q or Q1, so that's why we'll get here force experienced by the charge Q, that is Q by 4 pi epsilon naught. And this remaining thing will be same here. Okay, AR and divide by R square. AR is what? Unit vector. Okay. So now here we have trying to find the electric fields in different kind of the charge distribution. Okay. So here what we are saying that we have considered the different situations like we have line charge, surface charge and volume charge. Earlier we have seen the Coulomb's law or electric field intensity in case of point charge. Okay. Now here charge is distributed over the line, over the surface and over the volume. So in that case we are using the concept of that is the charge density. So here this length is the meter. So rho L is the charge coulomb per meter. Rho S is the surface charge density coulomb per square meter. And rho V is the charge density in case of volume, that is the coulomb cubic meter. So now by using the concept of that, what will be the total charge enclosed? So that is the charge density into the corresponding length or surface area or volume. On the basis of that, we are getting the total charge Q equal to integral of rho L into dl. So this is the over the integral of the line, over the line. Next, we have surface charge. So again here charge density is the rho s. So differential charge dq equal to rho s into ds. And finally, to find the total charge, you have to integrate over the surface. Okay, so that's why it is integral of rho s into ds. In case of volume charge, the differential charge is rho v into dv. Again, to obtain the total charge, we have to integrate over the volume. So this is the simple part where we have discussion in terms of different kind of the charges here. Okay, so next we'll have different situation where we'll see. So now here you see that these things we are going to write that electric field intensity for the different charge distribution. So earlier we have seen just the charge. Okay, so now here we have line charge, means in that case electric field intensity value is integral over the line rho L into dl by 4 pi epsilon naught R square AR. So in place of Q, what we have substituted here, rho L into dl. Since general expression of electric field intensity is what we have, Q by 4 pi epsilon naught into R square, and this is the unit vector ER. So now in this, in the different situation, our Q is going to change. So here Q is rho into dl. In case of surface charge density, Q equal to rho s into ds. This is the integral, okay? Integral, again here also Q is integral of rho s into ds. Similarly, in case of volume charge distribution, total charge is the volume integral of rho v into dv. So this is the surface integral. This one is the line integral. Okay. So this is the rough idea how you got this expression. So later we'll have different situation we are going to take. On the basis of that, we'll see. Now first one is what here? We have considered the line charge distribution. So in case of line charge distribution, this line is placed along the z-axis. So here, this is the AB is the line, okay, which is placed along the z-axis. On this, we have to consider the differential length. So this portion, DL is the differential length here, okay. So that coordinate of this DL, we are considering that it is located at the Z dash distance from the origin on Z axis. So that's why it's 0, 0, Z dash. Since on the Z axis, you know that X and Y value are 0. Okay. And here we want to find the electric field intensity at some point P. Okay. And the coordinate of P is X, Y, Z. So finally, here, what we are doing, we are connecting both ends of this wire, that line charge A to the point P and B also to the point P. And again, this differential element DL is connected to the point P. So finally, here it is important that the differential element that is connected with point P having position vector R, and this angle is what? Alpha. Okay. Later we'll see that this alpha is only going to change. So now here, when we are connecting the B to the point P, that angle is alpha 2. And when we are connecting A to the point P, this angle is what here? Alpha 1. So this angle is formed where this P is projected on the Z axis. So that is the distance from the Z axis. So that distance is what here? Rho. And here, due to DL, this is the differential electric field intensity, and this is the resolved in the rho component and Z component. So this is the D rho and D Z. So here this angle is what? Alpha. So when it is joined like this, okay, so this angle is what? Alpha. So finally, what will happen here? This angle also will become alpha since vertex opposite angles are equal, okay? So that's why this is going to be the DE rho, and here normal is what? DEZ. So later you'll see that this DE rho we can write in terms of D by in the cos and all these things. So this is how we have drawn the diagram. So to understanding the diagram is very important. Now later if you see that when this line charge is going to become infinite in the length, then we'll see that how this value of alpha 1 and alpha 2 is going to change. Okay. And rho is the perpendicular distance of the point P, okay, to the from the Z axis. That we have to keep in mind. So now here first what we need to find total charge. Okay. So total charge value, similar concept here, it is what? Line. So in case of line charge distribution, our charge density is what here? Value of charge density, rho L. And differential length, that DL is along the Z axis. That's why it's written as the DZ. So, and the two ends of this line, one is the ZA, another is the ZB. So finally, this DL is can be written as DZ dash, since coordinate of DL we have taken as 0, 0, Z dash. So that is the coordinate of which one? DL. And DL is what now? DZ. So that's why it become DZ dash. Now you have to find the position vector R value. So that is the final position minus initial position. So this X, Y, Z is the coordinate of point P, and this is the coordinate of the differential length. Now that what we are writing the DZ dash. So finally, just we have to subtract final position minus initial point coordinates. So that's why we have XAX plus YAY plus Z minus Z dash AZ. Okay. And if you see that, if you try to project that row, so that row is going to become here XAX plus YAY. So that we can see here. Okay. So that point, if you try to observe here how we are getting the row. So this row, if you try to project here, okay, if you think in that three-dimensional view, so in that situation, how this row is going to come, okay? So just have a look here. So this one is X, Y, and this is the Z. So now in this point, what we have here, point P, that distance is rho. So this one, we are going to project in the XY plane. So when we'll project this one in the XY plane, if you look in the way of 3 dimension, so that is point with this will be like this. So this length also will be what? Rho. So finally, if you find the coordinate of this, okay. So this length is what? This length is y. This length is what? X. So finally, this rho can be written in terms of x and y. So this is the ay and this will be the ax unit vectors. So finally, this head of one vector, again head of another vector is coming here, and here head and tail both are together. So this will be the resultant. So that's why rho we can write x ax plus y ay. Okay. On the basis, already we have a separate video lecture for this coordinate system also. So you can go through that so that you can understand this one in much better way. So now here we have substituted the value of r. Okay. Now finally we have to find the magnitude of r to replace the unit vectors. So we have that is r or is the magnitude. So r is the position vector. For that magnitude we can write like this. This is equal to written as the r. Okay. This is the magnitude of r vector. So finally, again, you are seeing that unit vector divided by r square. So unit vector we have seen many times. So that is what r vector divided by modulus of r. So that's why here r square become r cube, and this r is in the vector form. So that is the equal to rho a rho. Okay, and finally already we have z minus z dash az here. Okay, from this part. So now whenever we have like ax plus y in general, so for this magnitude will be what? Root under x square plus y square. So that concept is used here. So that's why magnitude is written here. Rho square plus z minus z dash whole square, and overall it is a square root. So that is 1 by 2, and it is the cube. So that is the 3 by 2. Okay. So now these values we need to substitute in another expression. Okay. So now finally that equation 1 becomes here E equal to rho L by 4 pi epsilon naught. So these values we are substituting here. Okay. So finally this is the R vector here. Okay. And this is the magnitude of that one. Now here what we'll have z minus z dash is here. Okay. So now this one, how we can write in the different forms so that it will be easy for us to simplify. So for that, if you see that in the given situation, if we'll have triangle in the previous diagram there. So this is the rho, and this is the r resultant vector, this is the angle alpha, and this is the z minus z dash. So magnitude, okay. So now here, how r we can write as the rho sec alpha. So that cos alpha, what will be the cos alpha value by seeing the diagram? Cos alpha is what? Adjacent side by hypotenuse. Okay, that's why rho by r. So finally from here, r equal to rho by cos alpha. And 1 by cos alpha is what? Sec alpha. So that's why it is the rho sec alpha. Okay. Now we have to find the z dash value. So this z dash is that complete distance of the point P what we got. So this point that is what point here. This is the T. Okay. So if you'll see in the diagram. So we have diagram in situation like this. This point is T. And here we have considered the differential length that is at z dash. Okay. So finally, and here we have origin. So what we can write the value of z dash in general completely. So that is you can write in this way z dash equal to OT minus this distance. Okay. So that distance is what? Rho or 10 alpha. So that's why it's written here rho 10 alpha. How we got 10 alpha? 10 alpha value is what? 10 alpha is what? Opposite side. by adjacent sides. Okay. So opposite sides by adjacent side, on the basis of that, you will get this value. So if suppose this is your alpha, okay. So this is the row already, and this one is, suppose we'll write here another point 80. So this row 10 alpha is what here? 80 by row. So finally, what will be the 80 value? Rho into 10 alpha. So like this, we are able to find the values. Now in continuity of this here, now these are the values. So finally what we have to find now? Here we have differential of dz dash. So now we have to differentiate z dash, okay, with respect to d alpha. So what will be the differentiation that we need to find in this situation? So finally here z dash, already we have this one. So here we have to differentiate dz dash with respect to d alpha. Okay. So OT is what? Constant. So for that is become the 0, and minus rho, and 10 alpha is what here? Differentiation of 10 alpha is what here? Sec square alpha. Okay. So that's why we'll get here dz alpha equal to dz dash equal to minus rho sec square alpha into d alpha. Okay, so that is the concept here, how we have written this one. Okay, so finally all values we are substituting here. Dz dash value as well as r value. Okay, by substituting all, we have expression equal to minus rho l by 4 pi epsilon naught integral over alpha 1 to alpha 2 into rho sec square alpha into cos alpha a rho plus sin alpha az into d alpha divided by rho square sec square alpha. So now here sec square alpha is being cancelled. One rho is being cancelled here. Okay. And finally, now we have to integrate this. So for that, the integration of cos is what? Sine, and integration of sine is the minus cos. So that range is going to change here from alpha 1 to alpha 2. Okay. So finally, this expression is reduced in this format where we have E equal to rho L by 4 pi epsilon naught rho inside the bracket. Now we have substituted the value of alpha 2 and alpha 1. So finally, minus sine alpha 2 minus sine alpha 1 a rho for this term. Again, we have to substitute in this term. So we are getting this part. Now, this is the general expression for electric field intensity in case of line charge. Now, we are going to consider the situation if this line charge is infinite. Okay, then what will happen? This B point is going to locate at infinity. So at the Z, its distance will become infinity. So that's why coordinate is 0, 0, infinity. And A is projected towards the downwards along the Z axis. So that's why its coordinate is 0, 0, minus infinity. So that alpha 1. So this alpha 1 is going to, maximum value is what? Pi by 2 when it's going to shift, and this is going to be minus pi by 2. So here what we are saying that in this situation, here where we have that alpha angle that you can consider. Okay, so that two different situation we have seen. Okay, so in that value here, this is the situation what we have earlier. So this is alpha 1, this was the alpha 2. So now this alpha 1 is, this point B is going towards the positive infinity. This point A is going towards the, this is the point P here. Okay, B is here. This is the T. This one is the A. So this A is going towards the minus infinity. B is going towards the positive infinity. So here this alpha 2 is going to change in the anti-clockwise. Okay, so maximum value, what will happen here? It will become like this. So this will become minus pi by 2. And this point A will become vertical like this. So this angle will become pi by 2. It is the anti-clockwise. So you know in the coordinate system, anti-clockwise angle is what? Positive for us. So that's why alpha is pi by 2 and alpha 2 is the minus pi by 2. So now this value we are substituting in this expression. So now this equation 10 is reduced at here value. What is the value of sine pi by 2? Sine pi by 2 is how much? 0. Okay. Sine pi by 2 is 0? No. Cos pi by 2 is 0. Okay. So sine pi by 2 value, how much? It is going to be equal to 1. So minus minus plus. Okay. And again here, if you have situation here, so this one finally, if you can see inside the bracket, we'll have minus is outside and sine pi by 2 value is 1. So that is the minus 1. Again here minus sign is there. So minus and sine pi by 2 value is 1. So finally this is going to become minus into minus 2. So that's become the plus and cos pi by 2 value is the 0. So that's why second term is 0. So finally here we have E equal to rho L by 4 pi epsilon naught into rho into 2. 2 is being cancelled. That's why we have here electric field intensity equal to rho L by 2 pi epsilon naught rho and along the arrow vector. That is the radially outwards. Okay. So like this, this is the expression for the line charge distribution. Okay. Next we have about the discussion of the surface charge distribution. So in case of surface charge distribution, we have to consider the surface. So this surface we are considering like this, that this plane is going to lie where this z is equal to 0. So z equal to 0 for this plane means it is going to lie where in the xy plane. Okay. So this surface we are considering where z equal to 0. So that's why this surface will come where in the xy plane. Okay. So now to understand this charge density of this surface charge already we have seen earlier. So that for the surface charge density is the rho s. Now we are trying to find the electric field intensity at the point P, and for the symmetricity purpose, for the better calculation, easy calculation, this point P is considered as the located at the z axis at height of h. So that's why coordinate of P is 0, 0, h. And here point 1 is considered here on the plane. Okay. So that point 1 is located at the distance of rho from the origin. Okay. And finally 1.1 is, so this is the differential surface here, ds. Okay. A small differential surface is considered here. And this is located, connected with the point P. So that position vector is r here. And this is rho is making angle alpha here. So this alpha is going to change. So alpha, you know, it's going to be changed from the 0 to 2 pi. And for the symmetricity purpose, we are considering the another point 2 also. So now finally what you see that this is the due to surface D1, this is for the surface D2. That is surface means that the differential surface what we have taken 1, due to that it is the DE1, and for the symmetricity differential surface we have 2, for that it is the DU2. So now if you will try to resolve this component of DE1, so that will come like this. This is the DE1 along the z axis will come. Okay. And this will be again opposite. This will be the for the DE1. So that direction will be which direction? This will be the negative AY. Okay. And similarly for the DE2. So again, so that also will have vertical components. So that will be DU2Z along the Z axis, and this will be along the Y axis. So finally, these two components are being cancelled. Okay. So only we'll get the vertical components here in case of infinite seat. So that situation will be more clear in further derivation. Okay. So here what we have to find the total charge. So differential charge is dq equal to rho s into ds, and finally total charge will be integral of that. So q is integral of that we have seen earlier, right? So if you have to find the total charge q here, so that will be the integral of rho s into ds. So now first we are trying to find the differential electric field intensity at point P. So that's why using the dq only. So d equal to dq by 4 pi epsilon naught r square, and ar is the unit vector here. And the similar situation here what we have seen. So now in this case, if you see that this r is projected here, so this r direction is this way, and if you have position like this, and if you are going to connect this, it is the radially in this way. Okay, this is the arrow, this is the r vectors, and finally this is the az. So now to obtain this resultant, az will be shifted here. Okay, and finally direction of this one arrow should change. Then only we'll have head and tail combination. So this will become minus a rho, and this will be az only. Okay, so that's why r is written as rho into a rho plus h az. This height is what? H. This distance is what? Rho. Okay, so that is the in the vector form. So finally magnitude of that is modulus. That is the modulus of r equal to root under rho square plus h square. Now in this, if you see that there we have considered the differential surface. So that differential surface, what will be the area of that differential surface? So it is radially outwards. This will be d rho, okay? And this is the arc of this, like you are finding in case of circle. If you join this here, okay? So this angle is what? D phi. So finally, this total radius is what? Rho. So this will become rho d phi. This is the arc of the circle. So like this concept, if you use here. So finally, if you want in the vector representation, this is the d phi. This is the arc. This one is the rho. Okay. So what will be this value? Rho d phi. So that's why here one side is rho d phi, another is the d rho. So finally ds is what here? Rho d phi into d rho. And this all already we have separate video for this lecture about this coordinate system, spherical coordinate system, Cartesian and cylindrical. So that you can also watch there. Okay. So like this we have discussion. Now finally all these values are substituted here. Okay. So this expression we are getting dE equal to rho s. Rho s is the surface charge density, and this is the value of the ds, rho d phi into d rho. This one is the value of r, and this is the again magnitude of the r. So that's why now this expression, due to symmetricity, what will happen? It will have component only along the z component. Okay, that a rho is going to be 0. So since it is the radiating outwards, okay, so that radial component is going to be 0. It has only component along the z axis. So finally, now we'll have calculation about this. So that is the values. So finally, if you see that here, how it is going to change, pi value is going to change from the 0 to 2 pi, and rho value is going to change from the 0 to infinity. Okay, so when this this we are considering that here infinite seat, so that due to this r is going to be maximum infinite, and if this seat is going to shrink, is thanks to 0, then rho will be almost equal to 0 or thanks to 0. So now finally we have to integrate here. So this integration, so what is the variable here? On the basis of that you have to see. Okay. So now in this portion what we have, phi is variables. So phi is taken separately, and phi range is 0 to 2 pi. H is constant since point P is placed at the distance of h there. Now here this one we are going to differentiate with respect to rho. Okay, that is going to change. So finally, this rho square plus h square to the power 3 by 2 is written in the numerator. And here, if you see that inside what we have, rho square. So that's why here it is written d rho square by 1 by 2. If you will differentiate this, what we'll get here? 1 by 2 into 2 d rho. Okay. So that's why this 2 will be cancelled. So finally it is equivalent to d rho. So this d rho what we have here, okay, that this is the 2 here, and again we'll have rho, okay. So like we have x squared by dx, that is going to be the 2xm, right? So similarly here, if you are differentiating this one, here we'll have 2 rho also. So 2 is going to cancel. This is equal to rho into d rho. So in place of rho into d rho, what we have written here, half into d into rho square. Now we have to integrate this. So that integration of this one is rho square plus h square minus 1 by 2. So this is what we have here, minus 3 by 2. And this is added here, 1. So what we'll get here, minus 1 by 2. And that's why it is being divided by minus 1 by 2. And this 1 by 2 is already here we have. And now 0 to infinity, substitute the value of infinity as well as here 0 in place of rho. Then we have a simplified version of this one. So finally you see that what is the expression of this electric field intensity. So now finally it is reduced here. Okay. So what is the expression? E equal to here, E equal to rho s into h by 2 epsilon naught. And from this bracket we are getting 1 by h. And this is along the z axis only. Rho, we have seen that rho is going to cancel. So finally, electric field intensity equal to rho s by 2 epsilon naught into Az. This is the general expression for the infinite sheet. Okay. So that is going to be along the z axis. Now, if you want to that, here we have taken h equal to 0. We can have h equal to negative also if that point is the opposite sides. So then this unit vector Az will be replaced by the minus Az. So in that case, this electric field intensity will become rho s by 2 epsilon naught, and this An is considered as the normal vectors. This will be always perpendicular to the surface. If it is towards the positive sides, it will be negative. Positive sides means like P was here located at the H. So then it will be the positive. Otherwise, An is going to be that is going to give her the negative sign. So both are being satisfied there. So now finally here we can see application of that one in case of two parallel plates. Since plates is what? What is capacitors? Capacitor is the two parallel plates separated by some dielectric mediums. So two plates means that also having surface. So one is the positive, another is the negative. So for this charge density is the rho s. For negative plate charge density is the minus rho s. So finally, this electric field intensity formula is applied here. So for this normal is upwards. For this normal is what? Downwards. That's why sign is An and here minus An, as well as charge density. This is the due to plus Q is there. So that is the rho s. And here charge is minus Q. That charge density is the minus rho s. So finally this minus minus is the plus for the second term. So we have here rho s by epsilon naught. So what we have here, rho s by 2 epsilon naught plus rho s by 2 epsilon naught. Okay. So finally, while you'll add this, you'll get this expression. So this was discussion in case of when surface charge distribution. And now we have seen in case of parallel plates. Next is the in case of volume charge distribution. So to understand the volume charge distribution, we need to have better concept of spherical coordinates. So in case of spherical coordinates, variables are r, theta, phi. So now in this here a sphere is considered. Inside the sphere, a sphere of the radius r is considered, so that in case of a spherical coordinate, we have variables are r, theta, phi, and this r is going to change from the 0 to infinity, theta is going to vary from the 0 to pi, and phi is going to vary from the 0 to 2 pi. Now, in this differential volume is considered somewhere inside the sphere. Okay. So, for that, differential volume is located at the distance that coordinates r dash, theta dash, and phi dash. Okay. So that's why your differential volume coordinates are, it's not on the surface. Okay. This is volume. It is somewhere inside the sphere. Maybe it's just touching the surface from the inside. Some edges touching the surface from the inside. Okay. It's not exactly on the surface. That's why coordinates are not r here. Okay. It is r dash. Okay. Somewhere theta dash, phi dash. That's why coordinate is written like this. And again, this point P is considered here at the z axis at the height of z. So this P is 0, 0, z. Now, this differential volume due to this charge, what is happening at point P, that electric field intensity is the dE. So here also you'll see that you will have situation of the symmetricity. So finally, electric field intensity will be along the z axis, that we have dE z. So again here radially components will be cancelled. Okay. So it is important how we are drawing the diagram and how we are writing the coordinates. Now we have to find the differential charge. Differential charge already we have seen. Okay. What is the expression? dq equal to rho v into dv is the differential charge. Okay. So total charge will be integral of this one. That is the rho v into dv. Okay. So finally, volume, already we have considered that this sphere having radius a. So you know the area of the sphere is what? 4 by 3. That volume is 4 by 3 pi r cube. And area is what? 4 pi r square. Volume is 4 by 3 pi r cube. So in this radius, we have written a sphere with radius of a. So that's why volume become 4 by 3 pi a cube. So now we have to find this is the total charge. Okay, this is the total charge of the sphere. Now we have to find the charge content in the differential volume. On the basis of this, we are finding the differential electric field intensity. So now, again, now if you see that this unit vector AR, what we have here, so that is the resolved again, two components for that one, unit vectors. So that components, so R, we are able to write here AR in this format. So AR is what? Cos alpha AZ and sin alpha A rho. Okay. Now due to symmetricity again, this EX and EY is added to be 0. Okay, only this is in the Cartesian coordinates. If you break that DE, resolve this one DE, that will have three components, X, Y, Z. So only Z component is available, and X and Y due to symmetry it is being cancelled out. So finally, the electric field intensity at point P due to that differential volume is integral of d cos alpha. Why d cos alpha means? We have only along the z axis. Okay. So this is not available along the arrow. So now we'll substitute the value. So dv rho v by 4 pi epsilon naught integral of dv by cos alpha by r square. And this is the differential volume. So in case of spherical coordinates, you have, if you are able to remember, we have sides will be the dr, and we have rd theta and r sine theta d phi. Okay. If you have any doubt, see the separate lecture is available for the spherical coordinates. So here coordinates of these differential volume we have taken r dash. So this is the dr dash and theta dash. So r dash d theta dash. Again r dash sine theta dash d phi dash. So finally This is the differential volume. Now, how we are finding the R values here or R dash square? For that, we are using the cosine rule. So in the cosine rule from the school days, if you're able to remember, if it is not right angle triangle, am I right? Apart from the right angle triangle, if this is the angle theta, then how will be the value of cos theta? How we can write other sides of the triangle? So here cos theta is the sides or arms which is forming this angle. So that's why b square plus c square minus opposite side is square. So that is the minus a square divided by 2bc. So same concept is used here on the basis of we have r square. If you see our diagram, so in that diagram we have situation like this. This is the r. Okay. This is the z. This one is what? R dash. And this is the angle. This one is R. So now in this situation, same rules we are going to apply here, okay, on the basis of that. And this angle is whatever theta dash. So now R is the opposite sides here, okay. So similarly, what we can write cos theta dash for this, it is z square plus R dash square minus which side is opposite? R is opposite. Okay, so R square divided by 2z R dash. So this is being rearranged here. Okay, so we have expression for R dash square. So that we have to substitute in the differential volume. And again, further rearrangement we have to do to obtain the expression. So finally, you are saying this is the value of cos alpha. Okay, again from the diagram. Okay, again cos theta dash also we got. So now these two values we are going to utilize here. So now we have differentiated here cos theta dash. So this cos theta dash. Okay, so finally differentiation of cos theta is what? Minus sine theta. So that's why we have here minus sine theta dash d theta dash. And this side we have differentiation with respect to r. So these two will become the constant and differentiation of this r square is the 2r. That's why we have here and dr is already there. So finally from here we got the value of sine theta dash into d theta dash. This is going to be little lengthy derivation, but it's going to cover all types of the charge distribution. Okay. So finally, all values we have substituted here. Okay. So many equations we have in this part. So this phi is going to change from the 0 to 2 pi. Radius r dash 0 to a. Since we have considered a sphere with maximum radius of a only we have constructed. And r is having a range of z minus r dash to z plus r dash. So after this, now we have to integrate. So phi dash that is 0 to pi. Okay. Now in this part, now you have to do the integration. So in this r square is taken as the common. So once we'll take r square as the common, so inside we'll get here 1 plus z square minus r dash square by r square. Now if you try to integrate here, so what we'll get? For this you'll get the r and here we'll have r is to the power minus 2 into dr. Am I right? So finally this one what we'll get here? 1 by minus 1 by r integration of this. So that value is substituted again. So further rearrangement is done. Now we have to integrate with respect to a small r dash. So integration of, so finally multiple term we are going to get here. So we have finally rho v by rho v into pi by 4 pi epsilon naught z square. And here we have 4 r dash square into dr dash. So now r dash square integration is r cube by 3. So that's why we have this expression and we have to put the value 0 to 1. So once we have substituted this value, we got here 4 by 3 pi into a cube inside the integral parts. Okay. and this rho v pi everything is there. So now finally, electric field intensity due to volume charge distribution, we have Q by 4 pi epsilon naught into Z square, okay, into, so here this Q is what? This is the volume. 4 by 3 is the 4 by 3 pi A cube is the volume of the sphere and volume charge density is the rho v. So this total product is what? It is equal to Q that we have seen before already. So that's why in place of this vector Q is written. So E is Q by 4 pi epsilon naught Z square along the Z axis. Okay. So finally, in general, this point can lies anywhere. Okay. On the basis of that, we have written E equal to Q by 4 pi epsilon naught R square into, this is the radially outwards. Okay. This is the sphere is going to radially outwards. So these are the discussion about this volume charge distribution. Before that, we have seen line charge distribution and surface charge distributions. Okay. So keep on watching, like, share, subscribe. Okay. Thank you.